All right, here we go. So I set the denominator equal to 0, and I solve. So that gives me x equals 0. So my domain is all real numbers, but x cannot equal 0, which means my vertical asymptote is x equals 0. Horizontal asymptote, I compare the numerator's degree. The numerator's degree is 3 to the denominator's degree. The denominator's degree is 1. So that is a big over small case. So that tells me that we are in a non-horizontal asymptote case. Agree? Love it. X squared plus 6 equals 0. X squared is going to equal negative 6, so x is going to equal plus or minus I times the square root of 6. Since those are imaginary, we can't graph those. Okay? So that means that there is no restriction on this. So it's just all real numbers with no vertical asymptotes. We can have that. Compare degrees. I got a 2 on the top, a 2 on the bottom. That's going to be the same. Okay. So if it's the same, then it's the lead coefficients. So that's going to be y equals 2 over 1, or just y equals 2. For that. Yes? Onliners, good. Thumbs up. Awesome sauce. Okay. All right. So find me just the asymptotes. So find me all the vertical asymptotes and all the horizontal asymptotes for this or these 3 functions. Okay? Go for it. First one. What are the asymptotes? Vertical or horizontal? What do you got, Aiden? Y equals 0? The degree on top is 1, degree on the bottom is 2. Yep, so that's a small over big. So we said yesterday y equals 0. Yep, I agree. Vertical asymptotes for that one. None, right? Because that denominator can never equal 0. Okay? So that's the only asymptote on that one. Okay? Second one. What do you got, Luke? Do we agree with 2 for the horizontal asymptote? Did you mean y equals 2? Because remember, it's got to be in line form. Do we agree with y equals 2? Not getting a lot of takers, Louis. Okay. What you got? Y equals 2/3 for the horizontal asymptote? Couple more head shakes on that one. Yep, I would agree with 2/3 here, that the horizontal asymptote is y equals 2/3. Because it's the same over the same, so we have to take lead coefficient of the top and the bottom. Yep. Any verticals? Nope, no verticals there. Okay. Third one. Any verticals? Nope, haven't been a vertical one yet. Same denominator all the way through, so none there. Any horizontals? Why not, Luke? The top degree is bigger. Yep. So none. There's no asymptotes here. All right, love it. So, oh man, it was supposed to be smaller. Why is it not smaller? Too darn big. Click on it. Not let me do anything. All right, well, this is supposed to say that this goes on your extra note sheet page. But now let me go like this, and let me go back here, and then there we go. Now we can get to the properties. Maybe. Oh, let's just get it. We'll just delete it. Too big. Okay. So we got the next three things that we need to find. Okay. So this would be now step number 3 on your extra page, your cheat sheet. Okay? Step number 3 says we need to find the y-intercept. Okay? And we're going to find the y-intercept by, remember what color this one is. This one is usually green. We're going to find the y-intercept by plugging in 0. Actually, here, let me say that better. I got too many ins. We're going to plug 0 into our function. So basically, we're going to find f of 0. The y-intercept will always be of the form 0, comma, some number. And it needs to be in point form because it is a point. Okay? So again, this is just like horizontal and vertical asymptotes. It can't just be a number. Okay? It needs to be in point form. Okay? So that's step number 3. We're going to find the y-intercept. Okay? Step number 4, the next step. We're going to do 3 steps today. Okay? Step number 4 says we're going to find the x-intercepts. Okay? We should actually put here that this could be more than 1. Okay? We can only have one y-intercept because it's a function, but we can have multiple x-intercepts. So in order to do this, to find the x-intercepts, we need to set the numerator equal to 0 and solve. We're going to set the numerator now equal to 0 and solve. And all of our x-intercepts will have the form some number, comma, 0. And again, those will have to be in point 1. Yep. Then the next thing that we're going to do, but it's actually step 7. So you're going to save a bunch of space for steps 5 and 6. Because this will actually be your last step.
How much do we need for 7?
For 5 and 6, you mean?
No. Yeah, I guess.
For 5 and 6, I would save a lot of space because 5 and 6 are the big steps. Okay? So I would save at least like 10 lines or so. So go to the bottom of your page or something, and put step 7. Okay? So step 7 is we're going to find other points using a T-chart. And you'll see this on the next slide when we get there. But I like to make a mini T-chart for each zone. Okay? We're going to have different zones on our graph. I like to make a T-chart for each individual zone. Then that way it's not one big long T-chart, and I can put it right on my graph. Okay? But again, I'll show you what I mean by that when we get to this next page. Okay? Okay? So now for sure we're on pink. If you're in the room, we're on pink graph paper now. Okay, because we're going to graph this next one. If you're at home and you haven't printed out graph paper yet from It's Learning, that's fine. You can just do this problem and then just make a graph for these next two. But if you have graph paper, now would be the time to use it. Okay? We're going to graph without a calculator or Desmos for that matter. Okay? We're going to show all of our steps, and then at the very end, I'm going to show you a very quick, so from the graph, stating your asymptotal and end behaviors is totally easy, okay? Because you're just reading your graph. It's not, you don't have to think logically anymore about big numbers over small numbers or numbers, left side, right side. It's all going to be for you right there on the graph. Okay? So we planned our work all week long. We've been planning up to this point in time. Now we're going to work our plan. So what is step 1 on our page? Find the domain of vertical asymptote. So what do you think the first thing that we're going to do is? No! First thing we're going to do is we're going to write the problem down. So we have the problem written down. So we have the function written down right next to our graph. But yes, then the next thing we're going to do is now we're going to find the domain and we're going to find any vertical asymptotes. Okay? So how do I do that again? Set the denominator equal to 0 and solve it. So that would be move this down here. Whoa, you jumped. Okay, so I set the denominator equal to 0. So somewhere off to the side, I'm going to say x plus 1 equals 0. So x equals -1. Agreed? So my domain is all real numbers, but x cannot be -1. What's my vertical asymptote then? X equals -1. Okay. So now on our graph, we are going to put x equals -1 as a vertical asymptote. And so we're going to use a dashed line to do that. So we put a dashed line at x equals -1. Come on, work for me. Okay, so we put a dashed line at x equals 1. Now remember, when we described vertical asymptotes earlier, that function, our graph, cannot cross that line. Okay? Can't cross that line at all. Okay? So we got that. Fantastic. Step number 1. Done. What's step number 2? Find the horizontal asymptote. Okay? What is the horizontal asymptote for this particular problem? Y equals 2. Not just 2. Get that out of your mind, Louis. Okay? Okay? It's got to be in line form. Okay? So it's y equals 2. That's going to be another dashed line, right? From yesterday, we said that that was another dashed line up 2. Okay? Step number 3. How do I find the y-intercept? I plug 0 in. Okay? So my y-intercept is going to be 0, comma, some number. So if I plug in 0, so I've got to find f of 0. That's going to be 2 times 0 all over 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. 0 divided by 1 is 0. So I go through the origin for my y-intercept. Okay. Step number 4. Find the x-intercept. How am I going to find the x-intercept? Set the numerator 0. 2x equals 0, so x equals 0. So that would give me an x-intercept of 0, comma 0. Before you ask the question, the answer is yes. What was the question? The question was, do we have to find the x-intercept if we've already found the y-intercept? And the answer is yes, because they are not always going to be the same. If one of them is the origin, then the other one will also have the origin, but it could also have more. Okay? There could be multiple x-intercepts. All right? So we're good there. Love it. Now, what we have to do is now we have to find more points. Now we're on step 7. Okay? So step 7 would say, let's find some more points. So I'm going to try some points over here in this left zone. The best point to try is the next integer to the left of -1, so that would be -2. The second best would be the very next one, -3. And then just so that we see, let's go -10. Go all the way out to the end. Okay. Our function, once again, was 2x over x plus 1. Okay. 2 times -2 is -4. -2 plus 1 is -1. -4 divided by -1 is +4. 2, 3, and 4. -3 times 2 is -6. -3 plus 1 is -2. -6 divided by -2 is +3. Negative 10 times 2 is negative 20. Negative 10 plus 1 is negative 9. Negative 20 divided by negative 9 is positive 2.2. So we're there. Then we have this zone to do. So again, we already have a point at 0, so I don't need one there. We could try 1 then. 2 times 1 is 2. 1 plus 1 is 2. That's going to be 1. Right there. Then we could go out to positive 10. 2 times 10 is 20. 10 plus 1 is 11. 20 divided by 11 is 1.9. It is nice to have 3 points in each zone. Okay? And so then now we have enough points to graph our line, or excuse me, graph our function. It goes there, and it goes there. Now, I told you that it would be very easy to come up with end and asymptotal behavior. Well, here it goes. Ready? So my end behavior is going to be what the function's doing on the left and the right side of my graphs. So on the right side of my graph, as x is going to positive infinity, that's over here, my function is approaching 2 from below. As x is approaching negative infinity, my function is approaching 2 from above. That's over here. My asymptotal behavior, as x is approaching negative 1 from the left side, that's here. My function is approaching positive infinity. And as x is approaching negative 1 from the right side, my function is approaching negative infinity. Right there. Yes? Okay. Yes, sir.
You have to write the asymptotal behavior.
If it asks for it, yes. And this one did. Yep. Yep. Likewise, if it asks for end behavior, you gotta write, you know what I mean? Yeah. The only reason we had to do it here is because it asked for it. And I wanted to show you how easy it is from the graph. Okay? All right, what I'd like you to do now is I would like you to try this one on your own. Okay? Graph it, and then give me the asymptotal and end behaviors. Natasha, he's not talking. He's just writing, because you're just doing it too. That's what I get for my graph. Agree? What's wrong, Hayden?
I did not do that.
Okay, where?
I didn't do super.
All from the start. Yep. When you take the square root, you got a plus or minus. Okay. Then it did ask us for end and asymptotal behavior. So my end behavior is going to be as x approaches positive infinity, my function approaches -2 from the bottom, and as x approaches negative infinity, my function approaches -2 from the bottom. My asymptotal behavior, there are 4 of them because there are 2 asymptotes. So as x approaches -2 from the left, my function is going to negative infinity. As x approaches -2 from the right, my function is going to positive infinity. That's the left asymptote. And my right asymptote, as x approaches +2 from the left, my function is going to positive infinity. And as x approaches +2 from the right, my function is going to negative infinity. Agree? And that's just straight off of the graph. Okay? Questions, comments, concerns, clarification? With that being said, you can now finish worksheet number 13, or week 13's worksheet. You now have enough information in between your ears to do that. Also this afternoon, the formative assessment 4-1 will open, and that needs to be done by Sunday, along with turning in the worksheet, week 13's worksheet by Sunday also. Okay? So lots of things to do between now and 11:59 p.m. on Sunday.